Good morning, everyone. My name is Akash. Today, I'm going here to submit my final milestone on our project, implementing multi-class transformation using LLM, also called as TabulaX. Yeah, we have two input options. One is CSV file and database, taking input to database. Here, I will show you the final outcome of our project using CSV file now. Here, I have to upload a CSV file. Let me do that. Yeah, this is the CSV file upload. We have to click upload and process to upload the CSV file. Now we have to choose one column to show the transformations on each column. We have four types of transformation. One is string based, algorithmic based, numerical transformation, and the general transformation. To perform transformation on the selected column, we have to submit two input and output pairs. Yeah. Now we have to take two input and output pairs. These are comma separated. Yeah, the input should be in input and output should be separated with comma. Yeah. Let us take two examples. If we click on classify example, the classifier will find out which type of transformation it should perform. Yeah, here we can see that it is a string-based transformation. Now, if we click generate function, it will show the function on which the data is able to transform. And if you click apply, the changes will be occurred. Yeah, you can see that the new changes are applied to the CSV table. Yeah, same like this, we can also connect our database and also perform the same operations. If I can, yeah, let me connect my database and select the table. Yeah, this is people table in which my required data or the columns are presented. Yeah, let me select the same name and click on classify. This will show us the transformation, the which classifier it is used. And now if we click on generate function, the function will be generated, and if I click apply, you can see the output is changed. Yeah, let me show you another transformation. Now let us select weight. Yeah. Yeah, here we'll change the weight from pounds to kgs. Suppose it's 186 to 84.3, so that the kgs, the pounds to kgs. And if we assume 133 as pounds to 60 kgs, here we can click that. Yeah, here we got that it's a numerical classification using the classifier. If I click generate function, the function will be generated. Yeah, see, this is the weight. The weight has been changed to kilograms, from pounds to kilograms. Same, we can use this with the help of database also. Same, connecting my password, uh, typing my password and connecting to the database and selecting the table, selecting database and selecting a table also. Yeah, this is my TabulaX and this is my people table. Yeah, we can see that the database is uploaded successfully and classify and generate the same process. That just the input varies from CSV and database. Yeah, this is the project. Now let us go through some codes, front end and back end. If we see this app.tsx is our front end which consists of the uploader uploading and taking input files like CSV and database. This also shows all the options using the classifier and taking the input output pairs, everything. The main front end page belongs to here. This is the code of all the main page. Let me show you a database connection. Yeah, this is code for connecting the database to our project and fetching the table and columns from database. This code is for taking an input and output pairs. Here we have used React and tail end, yeah, so on, so much for the front end. Yeah, if we yeah, you have to submit only two example input and output pairs to perform the transformation. This is the code for it. Yeah, this is the backend code for our app, for our project. We have used fast API for the backend, and see, this is the entire code. This is the port server used for uploading CSV. This is to classify, and this is to generate function to run it on the backend, which is connected to front end. We have used React and Tailwind CSS in the front end, and we have used API for the backend and Node.js for the backend. We have used so much stuff in this. Yeah, this is the code for the backend code for the download button. Yeah, if you want to download the output as a CSV file, we can do that. And this is the code for the database connections. Yeah, this consists of the connecting our code to the database of our local CPU, local PC. This shows all the tables present in it and all the databases present in it. So we can fetch the required table from the selected database. This is the code of column selector. It consists of the column which we have selected from the uploaded CSV database. Yeah, we can upload single column. By the final review, we will be able to select multiple columns and perform on that. We are sure we'll try that and upload the same in the website and update that. Yeah. These are the more important codes involved in our project, and this is the normal index HTML page. Uh, yeah, this is the model. This is the code used for integrate model. We have used llama model, which is show beneficial for us. At the starting we have used with Mistral project, but we are inconvenient with that, so we have shift to llama. It is so beneficial and it is so easy. It makes it do our work in a simpler way. Yeah, here we can see all our transformation used. These are the numerical transformations. Yeah, these are the arithmetical, and here we coming to string transformation. Yeah, these are the most important codes, and these are the prompts based on our project to make the code easy. Now let me discuss a PPT presentation on our project. Yeah, these are the major learnings I have gained during my project implementation and trying everything. Yeah, I have gained so much knowledge and experiencing with LLMs, mainly Llama, which performs very intelligent and context-aware data transformation. Yeah, we also developed a refined table transformation. That is what our project is required, which categorizes table data into four transformations: string, numerical, algorithmic, and general. Yeah, we have designed. Yeah. We have designed a module transformation pipeline that will be interactable, interpretable, scalable, and capable for handling various transformations based upon the real-world data set. Now we have learned how to integrate front-end and back-end. In the front-end, we have used how to learn React, Tailwind CSS, and the back-end we used how to learn Node.js, which are efficiently and seamlessly user interaction. We also implemented UI UX implementation in the advanced level, and we also learned how to integrate database and consistent management. We also worked on the syncing transformed outputs into a structured based database and dragging the output into a downloadable CSV file. Yeah, we learned so many techniques to run a transformer based LLM models like Llama, Mistral, or GPU heavy dependence. Yeah, this is the structure of our project, which we have discussed in the milestone one. The main changes which were done from the milestone one are: in the milestone one, the primary change was the model. Initially, we planned to use Mistral 7B instead, but after some evaluation on some problems faced, we have switched to Llama because it is more compatible with the deployment and environment. It is also superior instruction following capabilities for all tabular transformation tasks. Confirmation of whether we achieved what we promised. Yeah, we have confirmed all the promises which we have done in the first milestone. Yes, all the objectives outlined in the first milestone recording were successfully achieved. We delivered a strong working classification platform and transformation pipeline integrated with a full stack application as initially promised. Each transformation, like string, numerical, or arithmetic general, was successfully implemented and tested and integrated with both backend and frontend as services as promised and planned in the first milestone. Challenges and hurdles faced during the project evaluation. Uh, we have we have faced a small problems, but which have wasted our time so much time because running Llama models on limited hardware. Suppose we have Google Colab with only limited GPU, which is required for our optimization uh, to ensure smooth execution. Transformation function generation. Yeah, and on column classification accuracy. With the help of classifier, we can classify our columns, which it has high accuracy in classifying columns into correct transformation. Yeah, we have also faced challenges in front and back end integration because the communication between the React based front end and the Node.js backend, especially during file handling and transformation result display. Data consistency with database. Reinserting transform data into SQL and NoSQL databases while maintaining data integrity and handling Schema mismatches added complexity to the pipeline. Reason for choosing a specific model used in the project. Uh, like I told, initially we moved with Mistral 7B, but we have faced some problems and shifted to Llama. I think that was the best thing we have did in a project. We choose Llama for this project due to its strong performance in instruction following tasks and accessibility for research purposes, especially instruction tune capability. Llama fine-tuned variants are well suited for tasks involving classification, reasoning, and generation. Llama models are open and community supported, making them ideal for academic and experimental projects without license recognition. We don't need any kind of permissions or any restrictions. We have no. It is free to use. Llama offers competitive performance even on resource limited environments like Google Colab, especially with 3B or 7B Mistral versions. Yeah. Wide support through Hacking Face and other open tools enable rapid interaction with debugging development. Other models. The reason for not choosing other models is there are few other models also, Mistral 7B, GPT 3.5, and Falcon. We did GPT because while highly capable, these models require API access and secure usage costs. To use GPT-4, we require the API process and API key, which is not free. It charges some money for us, which was not ideal for a resource constraint or self-hosted product. Our project is not dependent on wasting on your money. They are closed source, limited customization, and fine-tuning options. We rejected Mistral 7B because Mistral performed well in our early test, but it had high memory dependencies in practice, especially for local or collab-based deployment, and also leads to instability during inference. Yeah, the reason for not choosing Falcon's 7B is while open source and relatively lightweight, Falcons struggle with the prompt consistencies according to our project, like also transforming algorithmic and general tasks also. Yeah, deployment decisions and approach taken. Yeah, a functional prototype was deployed using Radio within the collab to quickly test the transformation pipeline. This allowed interacting path based on the input and output plus real-time classification and transformation, and rapid interaction and debugging. Front-end deployment. Talking about the front-end deployment, the front-end was deployed using Tailend React with Tailend CSS and Oxide template. It was structured for using deployment on platforms like Vercel and Netfly, providing a fast serverless experience with clean CI or CD interaction. Yeah, coming to the backend implementation with Flask, we used Flask. The backend server was built using Flask, choosing for its simplicity, lightweight nature, and ease of integration. Yeah, AI endpoint for file uploads and transformation request, and the downloadable CSV file. Yeah, model hosting and inference also. Llama models were used locally in Kola for deployment and demonstration. For production level deployment, future options include run pod replicator model for scalable information. Yeah, coming to database integration, MySQL was used for the strong both data transformation. The schema was required for the subset tabular data and can be extended for largely. No NoSQL data were found and used. Thank you.